Hey guys, it's Rising Prism, and today I'm going to be talking about an advanced Linux setup that allows you to have a full Windows desktop running in a virtual machine under Linux. So I have stable enough performance with this setup that I'm able to stream with it. I stream on Twitch at twitch.tv/risingprismtv, and with the setup I'm able to take full advantage of my GPU's performance even though it's in a virtual machine. So previously in this area, the rule of thumb was that you needed two GPUs for this to work. One for the host, which is on Linux, and another for the guest, which is on Windows. But in the setup I'm about to show you, I do this all on a single AMD GPU. I have the Sapphire Nitro Plus RX 580. And so, to give a little context about this, Windows virtualization today is not as necessary as it used to be due to Steam Play, which is a way to play Windows games in Steam with the push of a single button. It does have its limitations though, since there are games that still don't work on Linux, including many of the popular Battle Royale games like Fortnite, Apex Legends, Call of Duty Warzone, that sort of thing. And it's due to a variety of reasons. Some of them have anti-cheat software that don't work on Linux. Some of them use like DirectX 12 API for graphics, which isn't fully implemented in Wine yet. But one key advantage of the single GPU pass-through setup that I'm about to show you is that you can still use the full power of your discrete GPU on your host to play Linux games, whether they're native or Steam Play, but you can virtualize only the games or software that don't work yet on Linux. To me, this is a big improvement over the status quo for PCI pass-through because before you had to decide whether to assign your discrete GPU only to your host or only to your guest. And so if you assigned it only to your host, you couldn't play any games that don't work on Linux. And if you assigned it only to the guest, you would have to play games that do work on Linux in your Windows VM, which is more overhead. So in this setup, you don't have to do that, and both your host and your guest can use the full power of your discrete GPU, just not at the same time, which isn't a big deal for me because I never really use my VM like that, but it could be for some people, so keep that in mind. And another advantage is that you can support the Linux gaming ecosystem as a whole by having your Steam client report Linux for the games that actually work in Linux. And so hopefully you enjoy the video, and let's get into the screencast. So this guide is going to focus specifically on Fedora, but most of the concepts should apply to other distributions as well. You might just have to tweak how you set certain settings and which files you edit. And like I said, I'm going to link the guides in the description, so you should be able to garner from that what changes you might need to make. So the first thing we're going to do is get set up for the basic GPU pass-through, and then we'll add the specific steps for the single GPU pass-through later on. So the first thing we're going to do is update the software on the computer. So I do sudo dnf upgrade -- refresh so that it pulls everything, pulls all the latest software from the repos. The next thing we're going to do is install a package group called virtualization. So do sudo dnf install @virtualization. And then I'm going to say yes when it asks me. And since I already have it, it'll say complete. But for you, it should install multiple packages such as QEMU, virt manager, and libvirt, and that sort of thing. At this point, it's a good idea to restart your computer because when libvirt was installed, that's actually a daemon or a service, and so you need to restart for that service to start running, as well as to avoid any issues with running an old kernel or anything like that. The next thing we're going to do is edit our grub boot parameters. So grub is the system that helps you boot your system in Linux. So we're going to edit etc default grub. We're going to do that with sudo. And as you can see, I commented out some other attempts of doing this, but this is the these are the parameters that matter most. So since I have an Intel CPU, I do Intel IOMMU equals on, IOMMU equals PT. That's what's working for me. I know for a fact that the parameters are different for Ryzen, so be sure to check that level 1 text post that I link in the description below. And so after we're done editing the grub parameters to add these two parameter settings, we can get out of there, and then we can run this command, which I'm going to copy paste in, sudo grub2-makeconfig -o etc grub2 efi.config. That's going to regenerate like all the boot entries from the grub configuration file that we just edited. So now if you reboot, you'll actually see the option to reboot, to boot into the system with those parameters. We need to get our device IDs of the graphics card. So as you can see, the graphics card shows up as two different devices. One of them is the actual GPU, while the other one is the integrated HDMI audio device. We're going to need to pass through both of these devices for this to work. So let's take down these addresses and then save those for later. So now that we have those addresses saved, the next thing we're going to want to do is edit etc modprobe.d/vfio.com. And as you can see, it's the way I set it up is options space vfio-pci space IDs equals, and then the first address comma the second address, the ones we just copied, and then options space vfio-pci space disable VGA equals 1. That should make sure that the graphics card, which is using the VFIO PCI kernel module, is not going to produce any output back to the host while the guest is controlling the graphics card. And so now we're going to want to edit this, and I'll copy paste this in too. We're going to want to edit this etc dracut.conf.d vfio.conf. It should be a blank file when you open it for the first time. But we're just going to say add drivers plus equals VFIO, IOMMU type 1, VFIO PCI, and check the link in the description if there's any differences between this and Ryzen. I'm not too sure. So then we're going to regenerate the Dracut configuration by running this command, sudo dracut-f-kver, and then backtick uname-r backtick. So we're regenerating Dracut for the current kernel that we're booted into, which is what that uname-r subcommand does. So once that finishes, then we can reboot so that we have the kernel that's running the parameters that we set in the grub config. And so obviously for me everything was already set, so let's do cat/proc/command line, and we'll see that this computer was booted with the parameters Intel IOMMU equals on and IOMMU equals PT. So for this, make sure that the proc/command line, which is a listing of the parameters that the current kernel was booted with, make sure that has the parameters we set in the previous step. Now, so notice I didn't set the setting that forces or blacklists AMD GPUs to not be loaded, and I didn't force VFIO PCI to be loaded. So if you do ls PCI-NN or NNK, you should still be able to see AMD GPU for your Radeon driver. So, so now we should have a pretty good base setup for passing through the GPU. So you're going to want to open the software called Virt Manager, or Virtual Machine Manager if you're opening it from the search box. And I'm gonna show you the configuration for my machine. So I didn't change much, but I'll go through these screens one by one. Well, I guess I did tweak a bunch of things. So name, you can name it whatever you want, doesn't matter too much. OS information, yeah, it's set that to Windows 10. Performance, okay, here now we're getting into the main thing. So CPUs, so I have a 4 CPU system. I noticed that if I don't manually set this topology, the Windows guest doesn't properly get my 4 CPUs. It doesn't properly realize them, and I see the performance hit from that when I'm trying to run applications. So I manually set the threads to 4. I noticed that that worked for me. I believe Ryzen has specific configs that you need for that, so make sure to check that link that I posted. The next one is going to be memory. So I have 16 gigs of RAM. I give 14 to the VM. You can give however much you want based on your machine and what your performance desires are. So the boot options. So when you first start, you're going to want to change the hard drive from SATA to VirtIO. It can help with performance. You can also just do it with SATA and change it later. That's what I ended up doing on this one. And so yeah, you're going to want a disk. You're going to want to create a QCOW2 disk with a certain size, and you can all do this all in the graphical user interface. There's no command line needed for this. So some guides make you set up all the QEMU stuff on the command line. I actually prefer the Virt Manager for this. So you can set up a disk. You can also set up a CD drive, and you can boot from that. So that'll be so you can say add hardware and storage and CD-ROM device, and that's where you'll put your Windows ISO. So you'll boot into the Windows installer. You'll install this to the drive. Next thing, you can also set the network card to VirtIO, and that'll be better for performance as well. But you're going to need to install a separate driver, and that's the same thing with doing it for the hard drive. So if you don't want to, it's just a performance thing. It's not gonna make it work or not work. So you can save the trouble maybe in the beginning and then just change it later. So these are the PCI devices that we're passing through. You can do that by going to add hardware and then PCI host device and choosing. I already added my graphics card and my graphics card integrated sound device. That's important. Make sure you do that. I have a bunch of USB things I pass through, which is my keyboard, mouse, my microphone because I stream, and also my Bluetooth dongle because I use Bluetooth headphones for the audio. And then a bunch of, yeah, these things don't really matter. So that's my setup for the actual VM. Pretty straightforward. So now that we've seen the VM setup, let's take a look at the specific scripts I use for single GPU pass-through. So the original idea and inspiration for this came from a guy named Joe Knock90 on GitHub. and he has a guide to single GPU pass-through, but he uses an NVIDIA GPU. But I'll link that guide in the description below so you guys can take advantage of it. And I'll also link all the custom scripts that I wrote for my specific pass-through case for you guys, so you can take advantage of that as well. So the first thing let's take a look at is the libvirt hooks. So these are what automatically run when your VM is started or stopped. So it's going to be at etc libvirt QEMU hooks. Or sorry, do I have that backwards? Is it hooks/QEMU? For some reason that doesn't tab complete properly for me. But anyway, so yeah, you're going to want to check the libvirt documentation, which I'll link below, on how to set up this script. But basically, you're checking for the name of the script in $1, which is the first parameter, and you're checking for the action type in the second parameter, which is the ones I care about are prepare and release. So prepare, which is before the GPU starts up, I want to run my startup script. Release, after the GPU shuts down, I want to run my teardown script. So the startup script is basically going to stop all of the graphical services on the host and unload the AMD GPU kernel module so that the host GPU is not being touched. The host is not touching the discrete GPU anymore. Then, when we shut down the VM, we want to restart all those services because the GPU gets passed back from the guest to the host. So I just called two different scripts, which I wrote myself: bin polaris vfio startup.sh and vfio teardown.sh. So let's take a look at what those do. So bin polaris vfio startup.sh. So okay, looking at this script a little bit, of course you have your pound bang bin bash. That just means if you do / this script, it's gonna use bash to execute the script. So it could save you from typing bash this script. Set-x means every command that's run is also printed out, so it's useful for debugging. And then, so I'm running KDE, which uses the SDDM window manager. Other desktop environments run different display manager. Other desktop environment run different display managers. So make sure to check which display manager your desktop environment runs so you can properly stop it. So we stopped this because the display manager deals with running a lot of the graphical infrastructure for the desktop, like for example the X11 server. So we stopped that. There's a step called unbind VT consoles. I'm not sure exactly what that is, but that's copied from the guide. I commented out this EFI frame buffer because I was getting an error in the libvirt logs that that file didn't exist, so I commented it out. You may or may not need it, depending. Also, you may or may not need this line for the VTCon1, but be sure to check the guide and try what works for you. Then there's a sleep to avoid a race condition. So it's just sleeping to make sure everything's, all the above commands are just completed properly before we move on. Then we unload the AMD driver with modprobe-r AMD GPU. And then I had some other stuff that I was trying, but I don't think that's needed anymore. Here's the key. We use this thing called virsh node dev detach. And so that uses libvirt to handle all of the detaching from these devices. So you detach from both your GPU, which has this address, and the GPU audio card, which has this address. And so there's a slightly different format, but it's the same basic principle. It's the same basic address, just in a slightly different format, which you can see here and in the guide. And then you modprobe VFIO PCI, and that's going to be loading the VFIO module that we want the GPU to be using instead of AMD GPU. All right. Now let's take a look at the teardown script. So same thing to start for the first two lines, but then once we're tearing down, we want to remove all the VFIO PCI stuff. So we remove VFIO PCI, VFIO IOMMU type 1, and VFIO. Notice these are what we set in the Dracut configuration. And then we do virsh node dev reattach. This is really important so that we can pass back the GPU from the guest to the host. And this uses the same address format as the one we did in the startup script. So be aware of that. And we rebind the consoles. So now this says bind instead of unbind. And same thing, I commented things out when they gave me errors. And so then we mod probe AMD GPU. So now we're reloading the AMD GPU driver because we want the host to use the discrete graphics card. And we start the display manager again. Okay, so all of this stuff that's commented out, you don't really need to worry about. That was just different things that I had tried, and you don't need to copy that. So, all right. So now we've talked about the scripts and everything that I have set up for single GPU pass-through. And so now I'm going to actually show you a little video of what it looks like to boot up the VM. Hey guys. So I wanted to show you on my actual monitors what it looks like for me to boot up my VM in single GPU pass-through. So you'll notice that because we're only running a single GPU, the displays are going to go blank for a second while we stop all of those graphical services and while we pass the GPU to the guest. And so we'll be able to see that right now. So let's give it a shot. Let's start my virtual machine. So I'm gonna hit play. As you can see, yeah, the screens go black. And then if we did everything properly, it's gonna come back and we're gonna see some Windows output because the Windows VM is now controlling the GPU. So let's see if that happens. It's going to take a little while usually. And there we go. So yeah, as you can see, we got to the Windows desktop, no problem. We can take a look at my Radeon settings, and you can see that we have full utilization of the GPU. You know, it gives you stats, you can upgrade your drivers and all that good stuff. So yeah, just wanted to show you a little bit about that. And now let's try the other way. Let's make sure that when we shut down the VM that it passes back properly to the host. And so it'll take us back to Linux. And as you can see on my second monitor and now on the first monitor, we're back into KDE. So now that I showed you my single GPU pass-through setup, let's talk a little bit about the drawbacks. So first of all, there's this AMD Polaris reset bug. This is an issue specific to the kind of GPU that I'm using, but which basically means that if you start the VM, stop it and go back to Linux, and then try to start it again, it's not going to work unless you reset the host Linux machine in between. So this issue was actually fixed for other AMD architectures like Navi by a user named gnif2. But as far as I'm aware, for the Polaris architecture, the issue still stands. And I can link the relevant Reddit post in the description below. And so that might be an annoyance that you have to deal with, having to reset the host between startups of the VM. Another thing is that, at least on KDE, since I'm using the SDDM display manager, simply restarting SDDM causes you not to be able to log in. Like, you just get a black screen. And I checked all the logs and I found a workaround for it. And it has to do with a service in System D called something like KDE Global Shortcuts. I'll link to the fix for that. So if you basically, there's a hack that lets you disable that service, which does things like, the global shortcuts for the terminal, like Control Alt F1, F2. And so if you fix that, then you're able to re-log into KDE once the Windows guest passes back the GPU. But as it stands today, when I get passed back from the Windows guest, I usually just restart to fix any issues with Polaris reset or the global shortcut bug. So, okay, so that should about cover it. Thanks for watching. If you're trying to set this up yourself, if you need any help or have any questions, definitely leave a comment, and I'll try to get you sorted out. I'll try to help in any way I can. I have been doing pass-through for a couple of years now, but I just recently figured out the single GPU pass-through case, which actually improved my Linux experience a lot because I get to use my discrete GPU on my host Linux box. So for most games, I don't even need to boot into Windows. Alright, so that should about do it. Yeah, feel free to like, comment, subscribe, and have a great one. Bye.